Right, we're looking to find a rational function with these details. So let's take a look. Vertical asymptotes. Okay, these come from the denominator. Remember, you cannot have x equals -1, you cannot have x equals +1 as the domain. So the vertical asymptotes, -1, x equals -1 has come from the x plus 1. X equals +1 has come from x minus 1. So again, vertical asymptotes, you're looking at the denominator. It's like looking at domains. The x-intercepts, these come from the numerator. -2 has come from an x plus 2 factor. +2 has come from an x minus 2 factor. Okay, so again, vertical asymptotes, look at the denominator. X-intercepts, look at the numerator. If I was to FOIL this, I'd get x squared minus 4 and x squared minus 1. Now, you've done most of the work here because that possibly could be the answer, but it's not because of the rest of the details, the horizontal asymptote and the y-intercept. Now, if I look at y-intercepts, if x equals 0, if I look at this, I'm going to have -4 over -1. Whoops, that's a 1. That produces +4, okay? So, of course, that's not the answer. We're trying to find a y-intercept of 8. Okay, also, we've got this horizontal asymptote of 2. Now, if you remember your rules for horizontal asymptotes. Okay, so we have, supposing the degree is larger on the denominator. Remember, that's y equals 0. If we have something where the degree is the same, then it's the leading coefficient of the numerator divided by the leading coefficient of the denominator, so that's y equals 1. And of course it's not, it says y equals 2. So if I was to say just put a 2 in front of this numerator, so let's take a look at this. If I do this, 2 x squared minus 4 over x squared minus 1, okay, so I still have the original that I calculated from this. But now I've put a 2 in front. Well, that, of course, will give me y equals 2. So if I write this, 2 x squared minus 4 over x squared minus 1. If I just do the distributive law on the numerator, I'll get 2x squared minus 8, x squared minus 1. Now look, of course, if x equals 0, I will get a +8. -8 over -1. And of course, there's my horizontal asymptote of 2. So there's my answer. You could either write 2x squared minus 4 over x squared minus 1. Or if you want to do the distributive law on the numerator, again, just back to where we started, over here, 2x squared minus 8 over x squared minus 1. Either of those two are fine, but they will give you all the details that we have up here, okay? So that's finding the function. How about graphing it? Okay, so now you don't really need the actual function itself to actually graph this. You just use the details here. So we have asymptotes of +1 and -1. Those are the verticals. Horizontal of +2. We have x-intercepts of +2 and -2, and a y-intercept of 8. So apologies for this, that's kind of up the top there. Okay, so I'm going to extend these vertical asymptotes up here. Right, now, remember, if we approach the asymptotes and cross the x-intercepts, that's pretty much all I can do. You can also take a look at your graphing calculator. It'll give you hints about how to graph it. There you go. Right, now, so if I have to hit that y-intercept and avoid the vertical asymptotes, I'm going to do something like this, okay? So apologies for that, it's a little bit unclear up there, but take a look at a graphing calculator, take a look at Desmos. Remember, if you want to put that into Desmos, which is what we got, you can take a look at the graph. Now then, how about this last little piece here? I'm going to take a look at the graph. As x goes to infinity, can you see we are approaching this y equals 2 line? And you can think of that as that, okay? So we are approaching y equals 2, and that's the answer to that. As x goes to infinity, y, or f of x, heads towards 2, okay? It is this y equals 2 line. Right, finally, let's look down here. Graph the function. Now, to find a y-intercept, you set x equal to 0. Well, if that equals 0, doesn't matter what the rest is. I mean, this is going to be 4, this is going to be -2. We have a y-intercept of 0. Okay, so I'll put that on the graph over here. Now, my x-intercepts, well, it's already been factored, so here we go. Here, we're going to have a 0 of -4. So that's an x-intercept. We have a 0 of positive 2, so that is an x-intercept. I'll put those on right now, positive 2, negative 4. But remember this one. This is an x0 of 0, but it's twice, 2 times, okay? There's 2 of them, x squared. It means it's going to touch and turn here, okay? So those are my x-intercepts, but it will touch and turn. Okay, so I've got to think about this. I've got to, remember it's a positive, it's degree 4. This is degree 4. They tend to look something like this maybe, okay? End behavior, rising to the left, rising to the right. So I'm going to go through positive 2. I'm going to touch and turn at 0. And I'm going to go through negative 4. And that's okay. How far, where the minimum and maximums are, is not too important for this one. But that's pretty much just a rough graph of the function. Okay?